I want to thank you for joining us tonight on Spindle TV, your best source for CNC CAD/CAM training videos. If you're watching Spindle TV on YouTube, be sure to hit that. Well, that was the wrong intro file. That was the outro file, not the intro file. For that, I do want to thank you for joining us on here on Spindle TV. Hopefully you guys will jump in and join up with me here. And just now getting things back on track from a major loss. Hopefully we won't have a lot of buffering. I haven't got everything quite 100% yet, so we'll see how well things go with that. And be sure to say hi when you pop in. And we'll give everybody a chance, because I thought I posted the link earlier. I created the link, and I could have swore I posted it earlier. And then I got some questions as if there was class tonight and things, and evidently I didn't follow through and post it. I had it created, but I didn't post the link, so hopefully we'll see all you guys here in just a moment. Welcome, William. Hey, Baron. Sorry guys about posting the link late. I thought I posted it earlier. I created the link, and I evidently didn't follow through and post it on Facebook. I created the link and everything, and I could have swore I posted it, but then I got some questions if there was class tonight, and so then that reminded me that, hey, you forgot to post it. So sorry about that. Thank you all for coming back and joining me. It's been a while since we were out of class. I'm just now recovering from that major loss of everything, and so having to re-download my broadcasting software and just everything. It's been crazy, but hopefully we'll get back up to 100% here in no time and get back on the flow of classes. Welcome, Dennis. Welcome, Alan. Welcome everybody. And but yeah, it's been a crazy couple of weeks trying to get back on track from that loss. I know one thing that I have will never let that happen again. Backup. I've got backups everywhere. It's been crazy. Yes, thanks, Debbie. Hey, Ford. No problem, Ford. Glad you're back up and carving and everything. Yeah, what was it? A couple weeks ago or a week or so ago? It was a couple Fridays ago, I think. I don't know how long it's been now. I've lost track of time. But we had a series of storms and series of power outages. And, the power would go out and all that wonderful stuff. But then there was this one day, Friday. It rained for, I swear, like 2 minutes, a very light sprinkle, and the power goes out. And like, okay. So when the power came back on, the computer went through an update. And from that point of that update, it was an imminent, as it said on the screen, imminent hard drive failure. And so the hard drive crashed, everything was lost, and I ended up having to buy a new hard drive and reinstall Windows 10 and reinstall the Vectric software, and I lost about $10,000 worth of software that I'm not going to be able to recover. But most of the software and everything I was able to get back. The Vectric and the podcast software, evidently, you see me on camera right now. So we're back on track. It's just going to take a little while to build up my files again and designs and all of that. But now I have a lot of redundancy backup. I got off-site backup, I got on-site backup, I got all kinds of, I've got an UPS power supply in case the power does go out again. It won't shut down my computer. So I got a backup power supply. I'm hopefully covered now. And let me know if you guys are hearing me at all, because William is not getting any volume. So let me know if you're hearing my voice at all. Check 1 2 sound check. Anybody you guys hearing me or not? Okay. All right, William, you may need to check your audio settings in, bud. Sounds like other people are getting good feed through. So check your speakers, or check your volume. Make sure you didn't accidentally hit the mute button or something. All right. Well, guys, I've had this project designed once before I lost it on. I had to go back and redesign it. What we're going to be looking at today is a laptop stand, or it could be a computer stand. Depending on if you're using a desktop computer, you could probably configure it to where your monitor is being held up or something by this, with your tower sitting, somewhere else or what have you. But this laptop stand is going to have a articulating or pivoting type arm and head, and it's going to have some drawers for tools, for your router bits, for your router tools, your collets, and any other miscellaneous stuff, clamps and hold downs and things like that. And the way I've designed it is I've got it measured to where if it's mounted on the front of the CNC unit, that the drawer part and everything comes right under the tabletop. So if you have boards that are running, like if you're doing pass-through carving or whatever, this will not interfere. It will yes, I do have a fan. Hold on, let me shut that fan off. Believe it or not, that fan is 2 rooms away, and that's how well the microphone picks up every little noise that's going on. You're going to hear a bunch of Facebook tones here. Okay, but the drawer part of the case comes right up underneath the tabletop. So if you're doing pass-through carving and things, your boards can pass right over it without it interfering with anything. And then the laptop stand part will be able to swivel as well in different positions and out of the way of the tabletop. So let's take a look at the actual design. We're going to be in SketchUp, and we're gonna break down the design in SketchUp a little bit and look at the components and stuff, and then we're going to see about importing those files into Vectric so we can create the toolpath. Now, a lot of these parts, to be honest, can be made on the table saw. There's a lot of them that are just square cuts and things like that, a couple of dado cuts, and you can use your CNC for it for sure. Really, it's going to be the laptop support part that's really going to be the CNC cut pieces and things. But let's switch over and let's take a look at everything and see what we've got going on here. All right. So my audio for this screen should be set up as well. And so you should be able to see this screen clearly also. And we are looking at the stand. So if we were to just basically kind of revolve around this for a moment and take a look at it, basically it's a box construction. Now the actual mount that you see over here on the left, the actual mount to mount to the laptop stand, this is just something I threw up here. This is not going to be the finished piece to mount to the stand, because it's going to sit on the shelf You know, there's going to be a part that kind of rests on the shelf to support, and then on the front part of this lower white piece here, there's going to be bolt holes where we can clamp onto the frame to hold everything in place. But that's just I just threw that in there as a kind of a mix. We've got our drawers here. These drawers, let's see if I can grab one of these drawers here. Pull it out. So we've got, you know, they're 4 inches deep, and the top one has a little bit more room actually in it, but the 4 inches deep, so plenty of room for your router bit. If you put a router bit holder in there or something for holding your bits, there's plenty of room. Most likely the top drawer would be for your router bits because of the extra space in there. So what I'm going to do is I'm going to hide a couple of these parts so we can kind of see the inside. Let's go in and hide this part and this side wall here. Let's hide it. And so the drawer, the top drawer itself, has a lot of extra headroom in there for, and so I would assume that would most likely be the drawer that has your router bits, because you're going to most likely make a little tool holder that sits in the drawer that organizes all your router bits and things. These drawers are running on 3/4 inch by 1/2 inch rails, as you can see, and basically you know, grooves in the sides of the drawers and stuff for sliding back and forth. And you know, for closing the drawers and all, they will just slide. Oops, let me get back on track there. They will just slide on those runners and all for opening and closing, and it should be a fairly nice fit and everything. Now, all in all, this cabinet is got a let's call it depth, the depth of the drawers and all. This cabinet has a depth of 18 1/8 inches, or 19 1/8 inches, sorry. For some reason I've got my measurements set up in feet instead of inches. I don't know why. But 19 1/8 inches in overall kind of depth. And then the width is going to be 13 1/2 inches wide. So your drawers from across the front, about 13 1/2 inches wide. And so there's also a little area on the top for setting stuff and things, and it's going to be right underneath the tabletop. So again, the tabletop will be somewhere probably in, let's see if I can do this. Up at this top level here, the tabletop about 1 inch above this cabinet. The tabletop will be, so materials and things can pass right over it and all. Now, if we take one of the drawers out, and let's move that over here so we can kind of focus on it for a moment. All right, so we have a very simple drawer handle. The drawer handle is just a basic, let's see if I can revolve around this easily without making you guys dizzy. Just a very simple hardwood or plywood handle. I'm choosing to use hardwood for mine. And then followed by the drawer front. And then we have the drawer itself. Now, for the drawer, if you want to make the parts on the CNC, the side pieces will be a two-sided part. You've got a groove on one side, and then you have the dados on the other for the drawer fronts to fit into. And this is almost kind of a locking rabbit joint. So, for the construction, the front piece if I can grab, let's see if I can grab this front piece here and move it out as well, so you can see the rabbets on the side pieces. And then of course they've got their grooves on the back, so that would be a two-sided part. You know, if you're going to do it on the CNC, but these are parts that could, if you do have access to a table saw, these are parts that could be cut on the table saw as well. And let's get this, let's pull this drawer out. Now, technically, the front parts and all are going to be two-sided as well. You will have your rabbets on each end, and then on the back side you will have a groove across the bottom for the bottom panel, for the 1/8 inch bottom panel, and for the bottom of the drawer. And so very simple construction for those parts. And then of course the front panel will get screwed on, and then, you know, the handle to make up the entire drawer assembly. And all three drawers are the same size, except for the drawer front on the top drawer is taller than the other two. So we have the two drawer fronts are going to be about 4 1/8 inches on the two lower drawers, and then the upper drawer front is going to be 5 1/2 inches and everything. And if we look at the runner, the runner is, let me pull this out here. The runner is just going to be a 3/4 inch by 1/2 inch wood runner, whether it's a plywood wood runner or, you know, hardwood wood runner. Put some paste wax on it so it you know, flows nicely and everything, and it will be recessed into the side panels, as well as you know, for, you know, that's where it'll be secured permanently, and then the drawers are able to slide into that. And so you know, when everything's assembled, and then let me go ahead and get the side piece back on that'll make up the parts. Now the top piece, if we move this up, and let me get orientated to where I can move this to where we can all see it. Let's get the top piece over here, so we can kind of focus in on it. Don't get dizzy. Alright, so the bottom side of the top piece has this basically rabbet with a dado in one end, but going all the way around. And that will sit down into the construction. Let me get back onto a top view. That will sit down into this construction here, because you know, the drawers make up the face. So basically there's only 3 sides, a bottom, and then the top piece. And so when that top piece, oh boy, sorry about all the moving around, just trying to get everything orientated. I should have set up different scenes and stuff, but I didn't have time. But that top piece will then you know, sit down into that part, you know, and finish off the construction of the drawer. Now let's go ahead and close this drawer. Let's see if I can get this drawer closed properly. Work with me, drawer, work with me. All right, let me get my drawer closed. There we go. Lord have mercy. One of these days I'll learn this maneuvering around. Now, on the SketchUp, or not the SketchUp, but on the articulating arm, let's see if I can get all of these parts selected here. That should be everything there. On this articulating arm, this will be able to pivot in various directions and things. And of course, when you're, if you're doing pass-through carving, Travis, this is SketchUp, Google SketchUp or Trimble SketchUp, SketchUp version 8. And it's a 3D kind of modeling program that can allow you to, build constructions and things. And it's called SketchUp, SketchUp, and it's version 8, free version 8. It's free. Now, if you on this arm here that articulates and everything around, it will rotate. But if you notice that I've got it attached to a backer plate, which is going to mount to the side of the drawer. And the reason why I did this is if you did not want the drawer assembly part of it, then you can just mount this plate right to the frame of your CNC. You can mount this plate just right to the CNC just for the laptop articulating arm part. But I have it mounted to the side of the box. And where this, to kind of, where this takes us is, hell, it could be mounted on a wall. It could be mounted on our frame right on the front of the digital wood carver. Heck, it could be mounted on the side of the digital wood carver on the frame, where you guys stand and stuff, wherever you want to mount it. Or it could be mounted to this box. It could be mounted to, if you already have a freestanding drawer system, for that, for your tools and stuff. It can be mounted to a lot of places. So you will see that this articulating arm here is mounted to this back plate and things. And it's just mounted with screws from the backside into the bracket here. Now, on the CNC, each of these parts here have a width of 1.5 inches. They're made out of 3/4 inch material and then glued and assembled together. And so I made it that way for the simple fact that we could cut these parts out on the CNC. So if we take a look at one of these parts, let me get one of these out of here. And let's kind of spin around to it. You can see that the part has the shape cut out, and then it has these grooves. These grooves are 1/4 inch wide by 1/8 of an inch deep, and with both of the parts put together, they form a 1/4 inch by 1/4 inch opening that a 1/4-20 bolt can fit through. And in this case, this bolt would be roughly around 1/4-20 by 9 or 1/4-20 by 8 inches, and you can buy those at Lowe's and everything. Just a 1/4-20 hex head bolt. You can put a star knob on it for easy adjusting and tightening down when you don't want it swiveling and things. But they are basically each of the parts are carved separately, and then they are glued together. Now, as far as the round over, you can leave the parts square. There is plenty of room that they won't rub, but if they were tight and everything, you would round over the corners like you see here for so that it can pivot and stuff. But that round over is not necessary. But if you wanted to round it over with a router or something, you could. Or a bandsaw, you could just cut off the corners, for that part, however you want to do. And so for the adjoining part, let's move this out. For the adjoining piece, again, these are made out of 3/4 inch material. Could be plywood, could be hardwood. They are 5.5 inches wide, so they could be cut out of a 1x6 piece of material. But on this part here, we have the part that's cut out, and then we have our 1/4 inch by 1/8 inch grooves. We do have a hole, cut through or drilled through for, the bolts. Oops, sorry. You're gonna see that when I ran into the cabinet. Therefore, when those two are assembled together, they create that opening for, where our bolt can slide all the way through. From there, you will have 1, 2, 3, 4 of these 6-inch by 2-inch, I believe they are 2 inches, 6-inch by 2-inch links. You have 4 of them, 2 for the outside and 2 for the inside. And the 2 for the inside can be glued together as well to make that 1.5 inch link, and everything. And again, 1/4 bolts. These bolts would be roughly 3 inches, 3.5 inches in length, of course, 3.5 inches, so we can get a star knob or something on it. And then leading up to these two parts here, let me move one of these out of the way, come down here. And this part is just very simply a 3/4 inch by 6 3/16 piece that is, I also believe that is 2 inches tall. Let's see here. Yeah, 2 inches as well. And these will be mounted to the underside of the platen, which will hold the laptop. And then ultimately at the top of the laptop, we have a little small frame piece here that will, keep our laptop secure from sliding. Now, with this frame is a 1/2 inch thick material. Plywood, again, hardwood, whatever you want it to be out of. It could be glued together to make this frame. It doesn't have to be cut out of one piece or anything like that. But if I was doing it out of plywood, I would just mill it out of one piece. But this part would most likely need to have some kind of recesses, let's say right about here, some kind of recess so in the side, so you can access your USB ports, possibly your power plug, whatever it may be. So there'd need to be a recess on one side there for your USB ports. Now, if you have a USB ports on the other side, then also you would have wherever it may land, you would have that recess there as well to be able to access that USB port also. In the front, a lot of laptops have like a to be able to open the door. So somewhere roughly around center, you would most likely have a recess so you can access and open up the lid. However it will be, and I'll finish drawing that out. I'm basing this off of my laptop, which has my laptop is roughly 13 to 15 inches wide. I think I actually made my platen 15 inches wide. And let me measure my platen. Yeah, 15 by 10. So I would actually have to make my platen a little bit bigger to fit my laptop in. And I'll get all these measurements and everything fine-tuned everything as far as up to the platen is good to go. It's ready to go. But I'll get the platen, you know, fine-tuned and all for the laptop. But that would be something that you would adjust. You would get, you know, you would adjust the size to fit your laptop. Now, the total height of the drawers, William asked a question, what is, with the taller face in the top drawer, what is the total height of the top drawer? Well, the drawer itself, if we come back into, let me move this side panel here. The drawer itself is 4 inches tall. The drawer itself is, actually, let me pull a drawer out here. Bear with me a second. There we go. All right, the drawer itself is 4 inches tall. The inside, with the bottom and everything, the inside capacity of the drawer is 3 5/8 deep. Most bits are under 3 inches in length and all, so still plenty of room even in the lower drawers for bits. But with the headroom in the upper drawer, above that, let me get down to it. Above that 3 5/8, you also have an additional 1.5 inch material. So, you know, you've got 3 5/8, 1.5 inch. That's 4, 5, and 1/8 inches of headroom in that upper drawer. Plenty of drawer space for you know, whatever you may want to fit in there. Now, William also asked, given recent PC problems, what keeps the articulating arm from lowering if bumped? As we hate for it to bump the PC, some additional locking pins or springs, loading bullet lock might be warranted. Well, let's move over there. The clamping arms and everything are, you know, pretty well substantial enough. One of the things that you can do is, if you wanted to, use a smaller nut, and you could place a series of holes for different positions, to where you can slide in a locking pin, you know, when it's set in a certain position, because you don't want to limit, you know, how this would rotate. If you have one locking pin, then you only got one position you can do. But you can have one pinhole in these outside arms, and then on these inside arms, you could have an array of various pinholes for, you know, locking it in if you want that extra protection. But when this is clamped down, it's not going to move too darn much. But if you want that extra, you know, that precautionary tail, then put in whatever you want, William. I mean, that's the freedom of being able to work with, you know, a design and add in any of the redundancies that you want to add in. As far as springs, I don't know. You can put in springs. I don't know how much they'll help, you know, compression springs and things like that. But the locking pin of some sort would be better than a spring, in my opinion. You can definitely, you know, do that. Now, on the top here, which isn't drawn in as of yet, but let's see if I can draw it in here real quick. Stand by one moment. let's see here. Let's find. There's going to be 4 of these tabs that will be able to, when the laptop is in place, that will be able to swivel around to hold the laptop in. There's going to be 4 strategically placed of these pivoting tabs that will be able to pivot in and out of the way when you've got your laptop in there. I'll design those a little bit better, create a shape that is CNC friendly and things for those tabs, before I post this, the files and everything up in the Facebook group. But as far as the articulating arms and things, if you want more security than the, when it's clamped down, locked in, you can put a locking pin, that goes into a series of holes where you have different, 15, 30, 45 degree, positionings, whatever the case may be. But that extra redundancy, it never hurts. It never hurts to do that. You've got, bear with me a second. Let me unhide my star knob here. You've got, lots of options there when it comes to customizing this. This is just the blueprint, the floor print. I'm going to have most of the parts. I'm going to have a part list created for you guys, an actual cut list. If you're doing it on the table saw, I'll create a cut list and measurements and stuff. Everything will be broken down. If you saw that jig build of the wedge jig, you'll have measurements and things shortly. But this arm would be able to swing out of the way, again, making it clear. So if you were passing material through, you've got plenty of clearance. It's not coming anywhere near, your table. If I were to draw the table, like if we were looking from a side view, your table would be, somewhere in this realm and everything. And of course it stops here, so the gantry arms, won't be running into anything and all of that stuff. And of course, let me actually draw that over where it belongs. Oh, quit rotating on me. Bear with me a second. Let me get... Almost there. Oh, let's see here. So your tabletop, your CNC tabletop would be here, and this would be mounted on the front of the box. If so your material and everything would be able to pass through without interference and all that, with the CNC and all. So this is the project that we're going to focus on, and it's going to be a 2-part project. The first part is basically, as we're doing now, looking over the design, having a little bit of a discussion of things that you'd like to see. Is it look good? Something that you would definitely want to make for yourself, or at least adapt off of, such as William. One of the adaptations that he pointed out would be like a locking pin. The springs, I'm not sure about. I guess they would, help for ease of, positioning things and all. But the locking pins more so than anything. would be, you know, to keep it from drifting down or anything like that. But when those bolts are locked, it's pretty well set up. I mean, I have a 32-inch flat screen TV hanging on my wall off of this same bracket, and never once has that TV fallen. When I move it into a position, when I swing it around, when I'm in different places in the shop watching TV, not once has it ever, you know, moved from that position or dropped. You know, me shaking the walls when my miter saw is running, when my compressor's going, the whole building shakes, you know, like crazy. When my air compressor's going and everything, and not once has that TV ever, you know, moved or dropped down or what have you. I'm very confident in the security of the bracket and the setup. But that being said, extra redundancy, extra security, extra locking, it never hurts. Never hurts. Draw it in. You guys are gonna have the Vectric file for these parts and everything, and then all you have to do is add in some extra drilling holes and everything for locking pins, if you wish, if you must, if you will, and everything. So that would be one adaptation. I think I'm gonna make a tool holder. Very simple tool holder with some V-carved numbers on it, like 1, 2, 3, 4, 5, you know, so you can number your tools, that would fit into one of the drawers, and I'll include that with the Vectric file. I'll get that for you. And of course, what drawer you put it in, it'll be fine. But the top drawer, probably because the extra headroom, would be probably a good place to go. But the top drawer with all the extra headroom might be something for bigger, like your your headphones or earmuffs or shit, I don't know, whatever you want to put in there, tools and screwdrivers and what have you. For me, I would have spare, bits. Of course, I have all my router bits, but I have, spare parts, brushes and things like that, couplers and stuff, for spare parts for my CNC, whatever the case may be if needed. But yeah, whatever you want to put in there. Drawer, it's just storage, we always need storage in our shop for that. All right, so let's take a look at, let me get rid of this. I don't want this to be imported into the Vectric software. I don't want the star knobs to be bolted in because they're not drawn to scale. I will draw up some star knobs and create a vector file for them if you guys want to make some star knobs for your hex bolts and all that. There's some great videos out there about designing and that, those, but I'll put one in the vector file. But I'm going to go ahead and let's see, I don't want to delete them. I'll leave them there. I'll just delete them out of the file when I import it in. Now, when you import into the Vectric software, you don't have to break the your 3D model up. You don't have to break it up, it will do that for you. It will count all the parts that are in here, and it will break them up for you. And so let's pop over to the Vectric software and let's see how we would import this file and what the parts look like when they're imported into the Vectric software. So we're going to go ahead and create a new file, and this is going to be I'm going to set this up as a double-sided job. If I were cutting this on a CNC machine, then I would have to flip the parts over for the grooves on one side, the dados and things on the other for the drawer parts. But again, guys, really the CNC could be just used to making the parts of the articulating arm. All of the other parts could be cut on the table saw, other than the drawer handles and stuff. But all the other parts could be cut on a table saw, skill saw, band saw, whatever, if the need be, with just as easy. So it's not strictly just a CNC problem. And if you guys have the mini carver and things like that, and you want something like this, if you have the mini carver, if you got the stand with your mini carver, something like this could be mounted to the stand. the mini carver. I believe with the weight of the mini carver on the stand that this wouldn't counterweight it. It wouldn't make it tippy or anything, but you want to be aware of that. If you built your own little bench for your 2440 or mini carver to sit on, and you have some type of table or something, and you want some extra drawers, this could be something that could be attached to that bench, whatever it may be. Now, if we go back and look at the design, my largest part is going to be my side panels. So I'm going to take a measurement of my side panels here. And they are 18 3/8. I got to get that foot measurement off there by 14 and a half. So 18 3/8 by 14 and a half. So plenty small enough to be cut on the mini carver or the 2440. So I'm going to go ahead and make my length of my part 24 inches in length, and I'm going to make the height of my part 18 inches wide, just to, like if I were working on a mini carver. And let's do this properly. We're going to go 23 by 17. I don't want to reach my maximum limits on my mini carver if I was using a mini carver. So 23 by 17 by 3/4 inches thick. Now some of the parts are 1/2 inch. The part only, well, not the runners for the drawer slides. Those are 1/2 inch, and they're just square, 1/2 inch by 3/4. You could cut those on the table so easily. But the little lip around the top platen for the laptop, that's also 1/2 inch material. But for the most part, all the other parts are 3/4 of an inch. Now on this, I am going to touch off on the same side. And one of the things that I've been picking up on recently and stuff, and in my own carvings and all, is I posted a couple of videos from Peter over at CNC Nuts. He's out of New Zealand. He makes some good videos and stuff. And I watched a video on his not spoiling your spoil board, not cutting into it a lot, and how he does his setup and things. And it got me to thinking about, a lot of times I touch off on the top of my material for my Z0 and things. And when I set my cut depth, I set it to 3/4 of an inch. My material's 3/4, I set it to 3/4. And some of us, will set it to 0.78, meaning that we want to cut all the way through our material, and we're going to cut just a little bit into our wasteboard. But then our wasteboard gets beat up very quickly and things. And so I want to be able to, if my material is 3/4 of an inch, maybe if it's off a little bit, even if it's 15/16 or maybe 13/16, a little over 3/4, or whatever the case may be, I still want to be able to cut cleanly through my material and not spoil my spoil board. So therefore, I've been setting up and touching off on my wasteboard surface, making the wasteboard my 0 position. Therefore, when my router goes and cuts through, it's not going any lower than 0. So it's going to be kissing right along my wasteboard, and it's not going to cut into it as much. It'll cut all the way through my material, but it won't beat up my wasteboard as much. I might get some little small witness marks and things like that, but for the most part, it'll stay solid. So for me, I'm going to set my position on my workpiece for the Z0 position for the machine bed for the parts. I'm going to set it to touch off on my wasteboard, because these parts would be cut out, cutting all the way through. I'm going to set it for the machine bed. But again, set it for whatever you want. I just found this method to be very useful, that it doesn't beat up the spoil board as much. So I'm going to go off the machine bed for this. I will work off of the bottom left hand corner of my parts. I'll use my XY touch block or my jig, my wedge jig, right? Use my wedge jig. So I will, my wedge jig reference is off the bottom left corner, so I'll use that. And then as far as flipping, I'm just going to flip, because it is a two-sided part, I'm going to flip along the y-axis. Just be able to just flip it, you know, top to bottom, y-axis. And therefore, we'll click OK, and that will set up our workpiece. There we go. So now I want to import, and let me save my design here. I think I saved it, but let me just go ahead and save any changes or updates that I made. Alright, so with that file saved, I want to import into my Vectric software, Desktop, Pro, or Aspire. We can import SketchUp files. They're, you know, part of the file formats of what we can import. And so I'm going to go into my Documents, my CNC laptop stand folder, and I'm going to import this in. Now, my little wizard pops up for importing and everything, and if I look over here, I've got 66 parts, and most of those parts are not going to be used in things, but we'll see what all it brings in, because the platen I'm going to cut on my table saw and things like that. I'm not going to cut my platen on my CNC. That's just not necessary. But I want an exploded flat view. I want all the parts bringing in flaps, you know, exploded. I don't want them coming in as it was assembled. If I would have taken the time to color the inside face or the faces of my material, I could have actually selected a color saying, hey, this color is my top face, but I have multiple colors throughout, and they would all been the same color, but I have multiple colors running throughout my piece, so I don't want that. I'm just going to auto-orientate it with the largest face being the top face. Okay. The gap between the parts, just bringing them in right now, because I will end up nesting them. I'm just going to bring them in and space them out about 1 inch apart, which is fine. I do want Vectric to create circles for where SketchUp creates polygons. You know, I want nice circles instead of polygons. SketchUp kind of has segmented circles, polygons for their circles and all. So it's going to try to fit these circles true to the approximate, you know, SketchUp circles, which again are polygon type shapes. I want to refit arcs to boundaries. So this tries to fit arcs to the appropriate SketchUp files and everything. Now, this would apply for me if I was doing the three-sided view, so I'm not going to check that off. Now, my group imported parts. So create a group for each component, you know, in the SketchUp model. So I've got groups. You know, everything is grouped together in my SketchUp. And so I want to, you know, group those parts together in a sense, you know, so they're kind of organized together when it brings it into the file. I do want to keep the components starting with the underscore together, meaning this is a grouped component. You know, I want to keep them in the same area. You know, I don't want them spread out all over the place. I want to kind of keep them relatively in the same area together when it brings them in. And I do not, let's see here, replacing the outer boundary for flat jobs only. This creates a single boundary for the component, deleting all the other parts touching the new boundary. I don't want to do that. I want to be able to manually delete things that aren't necessary in these parts, because when Vectric brings in the SketchUp file, it's going to bring in and it's going to break down all my dados and my grooves and things as rectangles and stuff like that, and I want to be able to work with them manually myself. I don't want Vectric to kind of try to you know, replace that and stuff. So I'm going to go ahead and click OK to import those parts. Oh gosh. And here are all of my parts. Wonderful, wonderful, wonderful. Okay. So here are all my parts laid out nice and organized for me. For right now, I'm gonna go ahead and I don't need the bolts. They don't need to be in there. They don't need the star nuts because I'm going to redraw them and make them a little nicer. I don't want to use the ones I made in SketchUp because they are god-awful. I don't need these 3 parts here. They are not parts. They are just extra vectors that were created. Let's see. What up here don't I need? I don't need this part here. This part here is my little simulation of a rod, right? One of those, bolts or a bolt and things. Let's see, are there any more of those bolts? 1, 2, 3, 4. These are my 5, 6. I believe those are my runners, 3 on each side. So these are my 6 runners right here. These are my handles. This is my side panel, one of my side panels. The other side panel is eluding me right now. I believe it's this one, but it brought in the wrong face of that one. It brought in the outside of it instead of the inside, so it didn't bring in these parts here. But that's fine. They're matching parts, so I'll just go ahead and delete this one. And I will make a copy. Hold down my control key, and I'll drag up a copy of this one here because those 2 parts are going to be the same. Okay. All right. So now, if you are like me, like if I were to cut these 2 parts out on the drawer side right now, let me stop moving around. If I were to cut these 2 drawer parts out on the sides, my top on this part and my bottom on this part, when this is standing straight up, it would be opposite for this one. This would be my bottom here, and this would be my top. And in this case, that's, it doesn't matter, but sometimes, depending on how things get orientated when they brought in, you may want to mirror the parts, you may want to, flip them or what have you, because you might have a good face of material that you want to use, and you might have a bad face of the material that you don't want to use. And usually when we clamp our board on our table, we always clamp the bad face down. We want the good face up or something, whatever the case may be. But in this case, it doesn't matter. We just understand that this one's upside down. If I were to be correct in my, which it doesn't matter. I don't even know why I'm going into this, but if I were to be correct in my, to have the top, the bottom, if I rotated this off its center 180 degrees, then there would be my 2 parts. But again, it doesn't matter. They just I don't know why I even went into that long explanation on that. All right, so I've got my drawers. These 3 parts here are my 3 of my drawer fronts. These are the 3 drawer front parts. And this is my drawer side. Now this is a 2-sided part. So this part would be broken up, and some of these vectors in this part here would be sent over, copied over to the other side because they wouldn't belong on this side. What belongs on this side for this part would be my dado on each end, That's this rectangle here, this inner rectangle, and this groove, which is the bottom of the drawer. But this, let me see if I can, let me ungroup this to make it easier when you see what I'm pointing to. Ungroup. All right, so this rectangle here, this rectangle here, and this rectangle here, those would go on my front side, you know, because that's cutting the grooves and everything for the inside of the drawer. This rectangle here would be for go on the other side. So I would copy that over to, I'd right click and you know, move, not copy. There's no need to copy, but move to the other side. I'm not ready to do that yet because, as you can see, if you can see how well you can see, but when I have this selected, part of my boundary is being selected as well. So I need to kind of break some things up a little bit. So I'm only sending the vectors over and all. Now on the parts here where I radiused these pieces over, rounded them over on the ends, that's what all these vectors are here on the ends here. I most likely would end up deleting those and just make it cut as a square part, and then I would round that off with sanding or what have you. I mean, I could have my router cut deeper and deeper and deeper, you know, on each of these segments, you know, manually rounding it over with the CNC, but that would be such a waste of time when I could do it much quicker with sanding, with you know, a round over bit on my router table, with a oh my god, bandsaw, you know, any of that stuff. You know, after I glue, I would keep them square. I wouldn't round them over individually. I would glue the parts together first, the two pieces, this piece and this piece. I would glue those two parts together, and that way I could do all my sanding and clean up on the glue squeeze out and do any rounding over that I needed to do, because only one, you know, edge of each of these two get rounded over to create that full round over on the 1.5" part. So we have all of our parts. The SketchUp did a very nice job of bringing those parts in for carving. And the one thing that I can see, the one part that I can see is, where is my platen? Let's see, this is a drawer bottom. This is a drawer bottom, and that's a drawer bottom. So that would make this part here my platen. And let's verify that with some measurements. It should be roughly 15 by 10. 15 by 10, so let's measure. Alright, that's 8. Let's see what this is. Oops, vertical measurement. Alright, 13. So that is not my platen. Where is my platen? Platen. That's got to be my platen. Bear with me a second. Let me see how it brought that part in. Let me take a quick measurement of this platen here. It should be 15 by 10. And I believe (15 by 10). Huh. Where's my platen at? Let me take a measurement here. No, that's a drawer bottom. Oh, Platin, where did you go? Let's see here. Let's count these out. This is a side for my cabinet right here. That's one side. That's one side. All right. So Vectric brought in some of my parts face up, some of the parts face down, and it brought this in. This is supposed to be one of my side parts here. This is supposed to be this part here, but for some reason, I think it's because that I have that mounting bracket on it. So we'll have to do some moving around and bring in some additional parts and things. But for the most part, we've got that there. Now, each of these parts should be grouped together. Each of these parts should be grouped together, which is great for us because now when I go to nest the parts, and now for you guys and girls with desktop, you do not have a nesting tool, so you would have to just manually position your parts on your board, move them and place them for cutting them out and things. Let's stop for a second. Debbie Miller says, could you use a roundover bit on the CNC? Sure, you could use a roundover bit on the CNC, Debbie. You could use a roundover to round that over. Now that's an 1.5 inch radius. That roundover is, so you would need an 1.5 inch roundover bit. It's an 1.5 inch radius on there. You could probably get away with a 3/4 inch radius because I did make the parts wide where they don't bind with one another, so it really doesn't even need to be rounded over, to be honest with you. But you could get away with a 3/4 inch roundover on that for sure. Absolutely. All right, so let's look at our nesting tool here. I am going to use a 1/4 inch bit for the most of this cutout. There is going to be a couple of grooves that are going to be 1/8 inch grooves on my drawer parts. The drawer bottoms, it's an 1/8 inch sheet for the drawer bottom, so that groove for the drawer bottom would be cut with an 1/8 inch end mill. If you wanted to use 1/4 inch, for your drawer bottoms, you could, and use a 1/4 inch end mill to cut the grooves. That's fine. You can just change that size. Let's go ahead and let me get rid of these measurements. I don't want them nested as well. I'll go ahead and get those parts in, and I'll put in 1/4 inch for the tool diameter. I want a clearance of these because I am going to be, for the most part, I am going to be using 1/4 inch a piece. Now, for me, all of those square parts, every single one of them are going to be cut on the table saw. If I wanted to clamp those parts in my jig just to do the dado work, maybe I don't have a dado blade and I don't want to pass the parts over my single blade on my CNC, I can cut my square parts out, bring them over and clamp them on my table and just do all the dado cuts. I don't have to do any profile cutting, for that and all. And so the clearance between the parts, I would want enough clearance for my 1/4 inch bit to cut on, between two parts, but leave a little bit of material for tabs and things. So if I go 1/4 inch and 1/4 inch is a 1/2 inch, and a little room for some tabs, I'm going to go 0.625, leave an 1/8 of an inch material in between. And then on my border gap, the border gap is how far these parts you want them away from your edges, the edges of your board. Now, if you're using wedge style clamps, and you got clamps on top of your board, you don't want them being too close to where, and blocking where you're going to be clamping and stuff and all. You can always move them around and things, of course. But I'm going to be using, my little, this will fit fine in my little wedge jig. So I won't have any clamps in the way. So I'm going to have a 0 border gap. I'm going to let these parts go right up to the edge because, if I got a factory edge on my piece, or a piece of, if I've cut it down and all, why not? If it's square, it's square. So I'll leave 0 gap. As far as the rotation, rotating parts for best fit, I'm going to start off with a 90 or 45 degree rotation. I'll start with 45. And that will allow it to rotate up to 45 degrees to fit. If it can't rotate, if it can't fit between those, that 45, 0 to 45, then it's going to put it on another board somewhere. So I'll give it up to 45 degrees. And I don't want to mirror the parts for best fit, and I definitely do not want to allow parts inside of other parts. Now, because I have no waste areas, inside of these parts. These are all solid pieces and things. So there's no waste material, being cut away inside of the parts and things. The only waste area I have is here. And for the most part is I can move something over into it if I want to. Alright, so I'm going to leave those two unchecked. I'm going to nest from the bottom left of my board up, and I want to nest along the x-axis of that board. And I'm going to go ahead and select my parts once again, and click preview. Let's see how many sheets it's going to take to cut this out. All right. So now, because of due to the rotation of 45 degrees, it's creating a lot of sheets, a lot of wasted material. So let's get rid of that. I'm going to reset that preview, and I'm going to come back to 90 degrees here. 90, and click preview. Okay. All right. So on my small 23 by 18-inch sheets, I can see some, I've got a side panel and a handle and a link, one of my links on 2 sheets, those 2 get cut out. Side panel and a handle on a second sheet. So I got 14 sheets altogether. Now, up here in the corner of this sheet 14, these 2 links here would be able to fit this link and this link. There's no sense in, or even one of these sheets, there's no sense in having any of that dead space, or some of these parts can come down and fit on these sheets. The reason why it did not put them in these dead spaces here is because of my gap, my spacing requirement that I put in there, that 0.625 and things. But I can, move them around and get them to fit in, different areas and all. I don't have to use, all that. But, so this whole cabinet, all the drawer parts and everything, will be cut out of 14 sheets out of 14 23 by 18-inch sheets. So let's look at a sheet of plywood. So let's say if how many sheets of plywood would this take? So let's go through, and I want to create a sheet of plywood that is 4 by 8, so 120 inches by 48 inches and everything. And of that, I want to create a rectangle that is let's go the 18 inches this way and the 23 inches this way. And let's see how many I can get out of this. So I'm going to have 2 rows. And columns, I should be able to get 1, 2, 3, 4, 5, 6, 7, 8. If I want about an 1/8 inch kerf saw cut in between them. Let's go 7 and see how I can do. And I'm going to go a gap in between these of 1/8 of an inch for my saw kerf. All right. So 2, 4, 6, 8, 10, 12. All 12 sheets can, we don't need, this guy doesn't need to be there. This guy doesn't need to be there. Gives me plenty of room to space my parts out. And I can get all 12 of my sheets out of 1 sheet of plywood. So it'll only take 1 sheet of plywood to create this drawer system and everything. Which is good. Still give me a little bit of scrap plywood left over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I can get 12 of those sheets. And so this would take 1 sheet of plywood to make this entire cabinet assembly if I was making it out of plywood. Yep. Not bad. Now, a lot of these parts, if I was making it out of hardwood, maybe I wanted to make it out of oak or something fancy, you know. A lot of these parts are 5.5 inches wide. So if I go from here to here, you know, 5 1/4, sorry. So a 1x5 board will cut a lot of these parts. My drawers here, the drawer fronts, you know, a little over 4 inches. My big drawer front is 5.5 inches. So, you know, a 1x6 or a 1x7 board, a lot of these parts could get cut out of. It's just my cabinet sides for the carcass of my cabinet. Those are going to be, you know, the longer or the bigger pieces. Those are, you know, 13.5 inches by, this is one of my drawer, this is the top of my drawer, the lid of my cabinet, by 19 1/8. So I would most likely make the carcass of my cabinet out of you know, plywood. And then if I wanted to, my runners, my drawer sides, fronts, and everything, those could be hardwood if I wanted them to be, and all my, you know, articulating arms and stuff could be out of hardwood. My drawer bottoms are definitely going to be 1/8 inch plywood material and all. So did I go 120? I did 10 foot instead of 8, didn't I? Thank you, Peter. Thank you. Peter caught me. I did 120. I knew as soon as Peter said check your board, I was like, wait a minute, a piece of plywood is not 120. Let's go back into the size there. Yeah, let me size that down more appropriate. I thought it was looking a little rectangle-ish, Peter. Thank you very much. 96. It's 96. 8 inches. So with that, let's take a look. Now I'm going to have, oops, let's close this tool. Damn, let me close that tool. Close. Thank you very much. All right, so with that, there are going to be 2 sheets that would be cut out of a, you know, a 1/4 piece of plywood, or maybe not. Maybe not, because if I'm doing most of my drawer out of hardwood or something, then you know, I might only end up using a 1/2 sheet to cut this out. But with a proper sized piece of plywood, 4x8, thank you, Peter, we can see here that of the 12 sheets, We can get 8, 1, 2, 3, 4, 5, 10 sheets cut out of it. You know, and this parts here, based on my specs in my nesting, would require 14. I don't know, where did I get the number 12 from? 14. Okay, so we need we would need 2 more of these sheets. So yeah, 1.25 sheets of plywood. But again, if some of these parts are going to be made out of hardwood, then it'd be less than a sheet of plywood. Let's see here. Move that over. I'm going to take 14 sheets. Oh, you son of a gun. 14 sheets. So 1.25 sheets to cut this out if I was making the entire thing out of plywood. I don't know. I would like my, it would be a very decent looking, I could put edge banding on the plywood and make a very decent looking cabinet. But I think on my articulating arm, I would make a majority of that out of hardwood. Give it just a really nice look and stuff. Maybe a walnut or maple or something. But either way, so this is how we would import it in from Vectric, and then we would nest our parts and things. Now, after nesting is completed, if I go back into the nesting phase, when I click OK, all of my other sheets are not going to be accessible. I can't click on them or choose them or anything. Only my active sheet when I'm creating my toolpaths and things. And how you switch from one sheet to another is in the nesting tools is you would switch from sheet 1 to sheet 2, from sheet 2 to sheet 3, and you would bring those sheets forward to your active sheets, and then you could create your your toolpaths and things. Now I want to talk about this, how we would set this part up. Now this part here is the lid or the top of my cabinet. And so basically there is a 3/8 inch dado, or rabbet, let's call it. Well, this is a dado here on this side, but there's a 3-inch groove cut all the way around this thing. And so the first thing I would do is I would ungroup this part, and this rectangle here, which you can barely see in pink because it's also on top of my boundary, which goes all the way around. But this rectangle here and this rectangle here would be my path and everything. But if I created this and had my bit running along, let me draw a router bit here. If I had my 1/4 inch router bit running along, it's gonna stay within my boundaries and everything, and therefore when it turns that corner, it's gonna create a radius and stuff. And I need this to be so I don't have a whole lot of cleanup. I need this to be a straight cut. I need it to be able to go past a little. So what I would do in that instance is this guy here, if I hold down, I double click on him and put him in transform mode. If I hold down my shift key and drag this up a little bit, and you'll see on both sides, the top and the bottom, if I drag this up a little past there, now my router bit has room to travel beyond the edge of my board and then make that cut and clean it up and everything. Because this vector here is my piece, this vector here that I've got selected now. So I want to extend this vector beyond that part there. Now when it comes, oops, don't do that. Now when that router bit comes into here and everything, and it makes this turn. Again, it's going to give me a nice flat area there. You know, I won't have a radius because the router bit was able to travel past my boundary line, which is this boundary line right here. So we just want to extend that particular vector out a little bit. And so we would go through each of our parts and we would adjust our vectors accordingly depending on the cut we were making. So this one would be ready to go. So now I can create my toolpath so we can see what that looks like. This would be a pocket cut, and it would be on this vector here and this vector here. I would be cutting 3/8 of an inch deep. I would be using my 1/4 inch end mill, and this is all brand new software, so none of my bits are set up properly. I just got all the software loaded again. So we're going to travel 55 and 20 and click apply. And I'm going to do an offset cut, and I'm going to, this is going to be my sheet 4, sheet 4, and I'll name this part, this is my box top, and it's a 1/4 inch end mill. So if I calculate this and we preview that selected toolpath, let it finish up, and I'll turn it on its side so we can see what's happening here. And now when I cut my actual part out and I do my profile cut on this piece, cutting through my 3/4 inch thick material, using my 1/4 inch end mill, I'm not going to add tabs for this, just so we can see. I'm going to be on the outside of the line. I'm not going to add tabs for a second on this, and this would be my sheet 4 box top profile. I forgot to put the word pocket on the other one. And cut that out and preview that cut. And so that would be the lid for my box top. And you know, if we look at it, let's turn that color off. It's kind of throwing some things. And let's make this MDF or something light so we can see the color. So if we look at this, and I don't know why I said MDF, let's go with a maple plywood or something, so it's lighter. I got my dark shading turned on. So if we look at this part here and compare it to our SketchUp model, that is my lid piece here. So that's the part that's going to be cut out and everything. And so we would go all the way through and you know, of course, set up all of our toolpaths, you know, and things. And you guys are going to have these files. You guys here in a little bit, I'm going to double check all the numbers and everything, and then you're actually going to have this Vectric file already nested All the toolpaths are already created for you. All you would have to do is if there's any additional things that you want to put in, such as your locking pins, you know, your pinholes and stuff in your parts. What sheet is this? Sheet 5. Let's switch over to sheet 5. You know, on my linkage, if I wanted to create some locking pins for different positions, the first thing I would do is figure out what kind of positioning I would want to do, and I would create kind of a arc or a path. Then I would figure out what size my locking pin's going to be. In this case, we'll go with a 1/4 inch diameter pin. And then I would have this part follow this path. And I want a distance between them of, I don't know, 1/4 inch. A little bit more distance than that. Let's undo that. Let's go double that, 1/2 inch, you know. And I would be able to set up 4, you know, pivot positions that I could lock into on those parts. And I would put those wherever, you know, they needed to be. And in this case, let's find my center and draw a center line there, and then I could take these parts here and hold down my shift key and select that line there, and I could mirror by flipping about that line. Let's try it with a mirror copy. There we go. To create my, you know, pivot holes, depending on, and if I wanted these, you know, running the other way or something, then I could let's see here, turn that off and flip it to let's see here. Actually, I just rotate it. I don't know what the hell I'm thinking. Rotate. And position that wherever it may want to fall. However you want to do that. However you want to create your locking pins. You know, you would do that, you know, William or anyone, you know, get those drawn in. And now only one set of the links, only one set of them would have the locking pin holes like you just saw me draw. The other set would have a single position hole. You don't need those 4 holes. You just need a single hole to slide the pin through. When that head pivots or what have you, you can slide the pin through into one of the 4 holes or however many holes you set up, and it locks it into that position. Then you tighten your nut down or what have you, you know. But you do not need to create all 4 of those pinholes in all of the linkage parts. Only one set of them, you know, in that case, and everything. This part here on this particular sheet, I would actually end up, let me get rid of this circle here. This sheet would not be cut out on my CNC. I'm not going to cut a square sheet out on my CNC. I'm going to cut those 1/8 inch drawer parts, bottoms. This is a drawer bottom. I'm going to cut it on my table saw. So this part, in a sense, wouldn't be here. Now I'm going to leave it there for you, and I will put names in here. I will put text on these drawings telling you what each of the parts are. and then you can decide if that's a part you're going to carve on your CNC or if it's a part that you're going to cut on a table saw. And you can decide if you want to delete it or not, because if I take my 3 sheets out of the equation, my 3 bottom 1/8 inch sheets, they're not even going to be cut out of this 3/4 inch material anyway. Then I have lots of room to move a lot of these parts over and minimize my number of sheets. And now I'm down. I can get this down to around 10 sheets versus 14. Because these 3 parts right here, 1, 2, and this one here will not be cut out of this plywood, because this is 3/4 inch material, and these are 1/8 inch sheets, so they won't even be a part of this job. So I will take this and set this off to the side, and I'll name it as with the size dimensions and everything for you, so you know what size to cut your 1/8 inch sheets out of for your drawer bottoms. But they will not fall in they will not be in the carving area of the drawings, because they don't. This is set up for 3/4 inch material right now. All of this 3/4 inch material. Even on sheet 14, this part here, which has to be redrawn, it's absolutely incorrect, that width and everything. That's that top part. I think because my piece was tilted at a 45 degree angle, it actually brought it in at that 45 degree. But this part here is 1/2 inch material. So, the proper sized part, I'll be sure to bring it into this, drawing, but this part here would be moved off to the side as well. So it will have its measurements and stuff, but it will not be part of the this project, because it's 1/2 inch material. I will create a separate sheet for a separate job for 1/2 inch sheet, and anything that would be 1/2 inch would fall in there. It's only 2 parts. No, it's only 1. This part here. These 3 sheets are 1/8 inch material. So only 1 piece. Oh no, my runners. The runners are 1/2 inch material. So I'll have a second job set up for you guys with 1/2 inch material for all the runners and stuff, if you're going to be cutting these on your CNC. So again, I said in the post earlier today that more so than a class, I didn't know how well this was going to go or what have you, because it's more of a discussion than anything, on this. I'm not going to get into a SketchUp drawing, how to draw in SketchUp lesson. I mean, I can show you a couple of things, but there are much better videos on YouTube for how to draw in SketchUp. If you decided to, work with it, it's free, SketchUp version 8. And I will highly recommend Jay's Custom Creations on YouTube. He has a wonderful, wonderful SketchUp tutorial playlist. That's how I learned SketchUp, was off of his 40 or 50 videos, and they're phenomenally done. Just well done. But in SketchUp, you have basically different axes, just like your CNC. We've got X, Y, and Z. So red being my X, green being my Y, and Z being the blue. And so when I'm drawing, whether it be a rectangle and things, I can draw along these different axes, whether it be along the red axis or along the blue axis, which I got to get it to I got to be rotated properly. Let me get stop. Let's see here, 6, 6. and just typing in the numbers, the dimensions and everything, will create the shape. Push pull allows us to extrude, that single line vector and thing, to extrude that surface. And so 0.75 if I want a 3/4 inch piece. Once all the parts are, the part is basically constructed, then you can triple click on the part and hit the letter G for group or component. It's create a component, and that creates that component, and it's one piece now. When it's selected as one. To be able to edit this part, you have to double click into it to be able to do any editing. For instance, if I wanted to radius off this corner, I'd have to double click into it, so I could now come in and radius off this corner and then push pull this part away to round off that edge and things. And so, but if this was a grouped piece or a component and I was not clicked into it, and I tried to, I can draw on top of it, absolutely, but it's not going to let me push pull that part at all, because it's not, I'm not in it. But now if I actually take and connect from here this line, and this line, then I've actually created another piece that I can push pull up, on that part. But I can't go into the component. You see that little hash circle with a hash in it. I can't go into that part. When I extrude down, my limit is, the maximum limit is that surface. If I go beyond it, you'll see it go beyond it, but it just disappears. It's not there. So we have to double click into a part in order to be able to, work with whatever it may be to round off those edges and things. So SketchUp is, you have tools such as the offset tool. Offset tool, if I wanted to offset from an edge, I can offset my edge somewhat, and then I can push pull that out and completely create that, cut through part there. If I come in and draw a line from here to here, here to here, then I've separated this part from the rest of it, and I can push pull that and get rid of it. Then I can just remove any of the residual lines to kind of make this all one part by clicking on and delete. And so, I've created that U-shaped part, and that's how this part on the laptop stand was created, and things, minus the round over corners, so SketchUp is just a nice way to kind of draw things and visualize them, be able to get a visual of the finished product, and be able to see what it would look like, and get the dimensions. And if you're drawing it to scale, so therefore when you do that, when you import that file into the Vectric software, it's going to import it into to scale. Now my two parts that did not import properly, my platen and this part here, that is going to be mostly due to the fact that when the camera is looking at it, it's looking at it at the angle that it's pivoted in, and so it's kind of creating a shorter version of what it is, and kind of a squished, narrower version of this platen things. It kind of brought it in, in this fashion versus flat. So to combat that, I would most likely take my part here, and I would rotate it to where it was facing flat. and that way when I import this piece, then it would import properly in its proper size and things. But because it was at that tilt, it brought it off a little bit. Now, it did not do that for the smaller parts. It did not do that for the links and everything, the smaller parts. That is simply because they are, I don't know why. I was about to give an explanation. Because it's looking at the face here. And the face is a certain size and all. So it's looking at the face. And this was flat. So here, and this is flat in this horizontal position, and it's looking at the face, the widest area. Baron says, can you post a link to the SketchUp videos later? Yeah, I've got it right here in front of me. So give me a second, and I'll do that right now in the group down below. And also, I will, in the group, I will post a link to the SketchUp software. Bear with me 1 second, and let me grab his playlist of the SketchUp to be specific. That way I grab a specific, the specific playlist for SketchUp. And so let me go into his playlist. And SketchUp instructions. All right, this is the link that I'm posting in the group now, guys. This is the link to the SketchUp instructions on Jay's Custom Creations YouTube channel. He makes some wonderful videos, by the way. Aside from that, does some wonderful woodworking. And the link to the SketchUp software, this is the link to Jay's website to give him credit where credit is due. This is the link coming up to his website page about SketchUp, and on that page there are links. A version for the English London version for the UK, and then he's got a US version. You'd want the US version. He's also on that page. He's got some SketchUp keyboard shortcuts. And then, of course, that playlist that I just sent you, he actually has all the video links on that page for that link. And so that second link is to Jay's Custom Creations SketchUp page. And you can find the software download, SketchUp version 8, which is the software that I use, on there. It's the direct download link for the US version. All right. So SketchUp is, a wonderful environment, and of course, coloring and things like that. You can, come in and create, different swatches and things. You can, like, for instance, if I wanted a certain face of all these parts to come up, I could choose a. Oops, not that it's grouped right now. Let me ungroup it first. I could choose a face of that part with one certain color. Each face would have that one certain color, and I could tell Vectric to only bring that color in face up. That's the face of the part, and things. If I came into this part and let's say that I, this was my, oops. get into the actual part, you know, and you'll see that those links, those parts were created together, so it actually colored that one face for me already. Same thing here is if I clicked into this face and I painted it, the other face would, you know, for this part, which is inside there, it's backwards, it would bring that in as well. So we could give a specific face a specific color, and then we could tell Vectric to only, you know, that's the face, that side up, basically that side up, you know, kind of thing, and all. But you know, a lot of different things that we could do. We could literally, you know, come in to you know, different colors and all, so we could actually get a real life look of what it would look like, you know, if it was in maple and all. We can add you know, different wallpapers in here for different you know, side views and things, different types of wood grains and stuff. Just a nice little it's just a neat little three-dimensional environment. You know, if I was gonna put some 3D text on here, and I wanted the height of the text to be 1 inch and extruded out 1 inch, and let's say a Times New Roman align center, I can place, and then I can come in here and place it on the face of my component, and I could literally lay out like a 3D, you know, like if I was making a 3D sign. But even though that's you know, maybe I don't want that 1 inch, well, I can pull you know, those parts in and things if I wanted to, you know, bring it down, or I could just delete them and create a, you know, the proper size. But you know, I could do all kinds of things. So SketchUp is just a wonderful, nice little tool that we can use. If we were doing trim, let me get all this stuff undone here. Bear with me a second. Undo all my there we go. Let's say, for instance, on this top part here, this top of my box, that I wanted to do a round over. You know, I could come in, let's try to get lined up somewhat on the side here. I could come in and take and draw my line tool here to here. I could take my circle tool and here to here, and actually that would be a cove. I don't want to do a cove, I want to do a round over. So let's take this tool here, there we go. Get rid of those two lines, and okay, there's a round over. Thank you, Lord have mercy. I could come in and use what's called the Follow Me tool. The Follow Me tool allows me to select 3 faces or more, you know, all the way around, and I could have it follow me. So let's go ahead, and I'm gonna, since this is a component, I'm gonna draw the lines in real quick. So let me draw a line from here to here, from here to here, My mouse is, sorry, my mouse was stuck. From there to there, and from here to here. And now I can use the follow me tool, and I can come in, and I got to select my 3 faces that I just drew. Hold down the shift key and select those 3 faces, and open up the follow me tool and click on that, and it creates that, oops, that round over all the way around my part. You know, that nice round over. Creates the mitered corners and everything. You know, if I was doing a decorative trim on the outside of this, let's say it was a dresser drawer or something. Notice how the trim went downhill on that one because I drew my line off circle there. So I'm going to undo that real quick and fix that line. I was wondering why when my mouse was stuck, my line was backwards. So let's get rid of that line there. And let's draw that line one more time. From that point to that point. And one more time, let's select those 3 lines. 1, 2, 3. Click on the follow me tool, and then click on my profile, and the path does not appear to be valid. Let me see, why is my path not valid? Oh, vector selection is very important. The order that you select your vectors is super duper important. It's got to be able to follow that path. It is a valid path. What you doing there, buddy Ro? Let's start from scratch. Lord have mercy. Trying to show off a tool and don't even know how to use the damn thing. Alright, one more time. Let's start by getting this damn thing in the middle of the screen so we can all see it. Alright. We'll go from this corner to this corner, from this corner to this corner, and from this corner to this corner. Now I can select that path, follow me, and I can come in here and create that round over. Jeez. Live TV. Alright, so different things like that. So you can create all kinds of profiles and really neat stuff. SketchUp is a very useful thing, especially if you are into cabinet making or you know, dressers and furniture and rocking chairs and everything. All of my Adirondack chairs and things like that, all of that stuff gets thrown in. The project that we will be working on in a week and a half, the chair / step ladder that converts from a seating chair into a step ladder, that project that we're going to be doing, it gets drawn up in SketchUp and everything and all. So alright, so that's my brief little kind of demonstration of SketchUp. I'm not getting into a SketchUp tutorial. It's you know, crazy. It's not crazy, but I mean, it's just we don't have that kind of time. Watch Jay's custom creations. Watch his videos. Phenomenal videos. I knew absolutely nothing about SketchUp. Nothing. Not a lick. I downloaded the SketchUp. I watched start to finish. Had a little marathon. Watched every one of Jay's videos, and as I was watching his videos, I was pausing and I was doing the little, like, the video only covers like one particular topic, how to do this, how to do that, and I was doing it, and by the time I finished all, I think 50 of his videos, I was absolutely proficient in SketchUp. I'm still a little, you know, every once in a while I get a little janky, you know, forget how to do things like that follow me tool, you know, a little path error there and all, but we all have our bad days. But I can't say enough about Jay Bates. He's a phenomenal guy, phenomenal woodworker and stuff. So, All right, ladies and gentlemen. I will create this SketchUp file for you guys, and I'll post that in case you guys do get SketchUp and want to play around with it. I will get this. I'll make sure there's a SketchUp file of this project. You will have a Vectric file of this class project here as well. And what we're going to do is next week. Once I have all the measurements and have all the parts brought in properly and everything, I don't even know if we'll wait till next week. We'll probably have I don't know, I might throw up a surprise class on Thursday or something. I don't know. But one of these, Thursday or Monday, so we don't have to wait. So we have the weekend. If we wanted to make this, we can make it this weekend. So we might do a class on Thursday just for this project. But we're going to go in and we're going to look at each of these individual parts nested. And we're going to look at the toolpaths and how we selected the vectors and how we made the changes. It doesn't take very long. That is a time for another class, and I'd like it if you guys wanted to make this weekend as a project. I'd like to be able to have the part 2 class like on Thursday evening, for about an hour, because it shouldn't take but an hour session to show you how these you're going to have the file with the toolpaths already created, but you got to know how to do this. If you start drawing in SketchUp or if you start doing things, you got to know when you bring parts in how you identify all the different vectors that the Vectric draws from SketchUp, and how you would approach creating your pocket cuts and your drilling toolpaths and profile cuts and things. So that will be just a strict dedicated class on this project. And we will create the toolpaths and we will identify the vectors. Which vectors do we delete? Which ones do we keep? Because these parts in SketchUp are 3D parts. The parts in your Vectric are 2D vectors. But SketchUp brings in the additional vectors. So if I ungroup this part right here, you will see that we have our dotted line for our perimeter here, but it's not a dotted line. It is, there's something behind it. That's because Vectric is drawn this part up to here for the perimeter, but then it's also drawn not only this rectangle, but this boundary here. For this piece. We don't need that boundary. So this boundary here would get deleted. So we only have one boundary right there. Okay. We have this vector here, which is by itself. And then we have the rectangle for the dado. Well, we need this rectangle for the dado. And we need to make this rectangle just a little bit longer, holding our shift key down so the router bit can go right past, zoom, zoom, and stuff. And let me get in there. Come on now. Got to select that rectangle again. There we go. We will have that. But this rectangle, that's our perimeter. You can see our perimeter goes all the way around. We want to keep that one, but we don't want this one. So we can hit our delete key. I'll just right click and click delete, get rid of it, because we should only have a clear dotted line for our perimeter cut and a rectangle. That's all we need. So this piece down here, this part right here, this vector, we right click and delete that one out, and now we have a clear perimeter and a rectangle for our dado. That's the only two vectors we need to cut this part out. But Vectric brought in all the sides, and so it created the boundaries for all the sides. So this part here, we get rid of this vector, right click and delete, because we should have a clear dotted line. We should have a profile and two pocket cuts. In this pocket cut, we would extend out a little bit so the router bit could clear it. to give us a nice clean dado. So there's vectors that we have to delete that we don't need. We should not see any solid lines behind our vectors. If we do, that means there's duplicates. There's another line behind it. And so in the class on Thursday, we are going to identify all the duplicate vectors. We are going to remove them, and then we're going to create the toolpaths on all of our sheets and everything. Now, you won't have to, after the first couple of sheets, it's rinse and repeat for the others, right? So you won't have to stay for the whole class if you don't want to, because you will have this Vectric file with all the toolpaths and all the sheets and everything already, done for you, that I'm going to upload in the Facebook group. Say thank you. No, just kidding. But I want you to know how to be able to do this stuff. If you start experimenting with the with SketchUp and drawing your own designs in SketchUp and bringing them in and things like that to be able to cut the parts out and stuff, I want you to know how to be able to look at these parts and that the Vectric brings in, and how to get rid of the things that you don't need, adjust the things you do need, and go from there, because they are to scale. The parts are brought in to scale. So if I were to measure, let's do this dimension tool horizontally. If I were to measure vertically from here to here, this should be 5 1/4, and it is to scale. So it does bring in whatever you draw in SketchUp, draw it to scale, because that's how it brings the parts in. That way we don't have any other fuss and muss that we need to deal with it and stuff. All right, ladies and gentlemen, this was just kind of part one of this project. Now, before Thursday, you will have, here and probably tomorrow, you will have all the files. You'll have the SketchUp file to download off of the Facebook group. You will have the Vectric files to download. That way, when we come in Thursday, you can either, number one, start from scratch, and import the SketchUp file in and things and work with me along, as we go through. Or you can just open up the file that I give you so you can kind of follow along during the class and stuff. Now, the file that I'm going to give you is going to be clean, absolute clean. All the vectors and things that do not need to be there are going to be removed. To be able to cut these parts out and stuff. That way you could, if you just like, you know what, I get it, I'm just going to make the part, I don't need to sit in on that class, if you don't want to sit in on Thursday, then that file is going to be ready to go. Save your toolpaths, check them. Never take a toolpath for granted, even from me. Check your speeds and feeds and things like that. Make sure you're happy. Make sure it's using bits that you have. This project uses a 1/4 inch end mill and an 1/8 inch end mill. That's it. If you don't want to use the 1/8 inch end mill for the bottom of the drawers, you can change that vector and make it a 1/4 inch vector. Let's look at that real quick. That is on, that drawer bottom is on, or this front and backs, either one of them, the sheet number 11. So let's bring in sheet number 11. Okay. This little, let me ungroup this one. This little groove right here, this 1/8 inch groove right here, that's the drawer bottom in things. If you want it to be wider, then you draw, add another 1/8 of an inch to that, make it a 1/4 inch, if you don't have an 1/8 inch router bit, but you can go to Lowe's and buy an 1/8 inch end mill for $13 to $15, 1/8 inch end mill from Lowe's. You can go to Digital Wood Carver, 2-day shipping. We do have an 1/8 inch end mill. Now, I will say this, the 1/8 inch end mill from Lowe's is a 2-flute. In plywood and things, you're going to get a much better cut. The 1/8 inch end mill on the Digital Wood Carver website is a 4-flute. So it's got, it's more so for 3D kind of work and things like that, and pockets and stuff, plastics and all. You can, run down to Lowe's and grab you an 1/8 inch end mill and stuff. But if you have the 1/8 inch end mill from Amana from us and all, use it. It's there. It's just you're usually running a little bit slower speeds because the gully, the flutes are shallower than like a 2 flute 1/8 inch end mill and stuff. All right, any questions on anything, or did I put you guys to sleep? Because it's 9:15. We're gonna go ahead and end for tonight. This is kind of our stepping our tippy toes back into the water of the cold pool after being away for a little while. We got a big project here. Once we get past this project on Thursday, then next week we'll be able to do the chair step stool project. So I want to finish this one up on Thursday just to get done with it, and also Monday, this coming Monday, we can have a different project and all. So any questions on anything, or did you guys already switch over to Jay's Custom Creations and watching his videos instead of me? What is that? Y'all probably did. Y'all clicked that link like, oh yeah, this is cool. It's alright. Alright, so let's close this and alright, I'm not going to save the changes to this file because I'm going to make sure all my dimensions are correct and everything in SketchUp first, and then I'm going to come in and import those files in properly and stuff. So this will be what we're going to be discussing on Thursday, and hopefully I'd love to see if you guys built one of these. This would be pretty cool if you did. I'm going to build one. I'm making one this weekend, this exact one for mine. I need storage, so I'll be making mine. I'll be sharing pictures in the Facebook group of my finished piece and things. So that's going to be my weekend project for myself, this one. And hopefully one of the days you guys can make one. Peter Hearn says, can you cut cast acrylic with CNC? Absolutely. That's preferably the plastic you want to cut. Cast acrylic over plexiglass or Lexan and things, they tend to chip and break and melt and stuff, and you got to babysit them. Cast acrylic, that's what your edge-lit signs are made out of. You know, all those edge-lit, LED edge-lit signs and things. That's cast acrylic. So yes, absolutely, you can cut and carve and cast acrylic, and you use your regular tools, your regular V-bit, you know, your end mills and ball nose bits and stuff like that with cast acrylic. It's highly recommended to use cast acrylic over extruded plastics. Yeah, absolutely. All right. Well, I want to thank you, everybody who said thank you, and you're welcome. Thank you for spending time with me. We're going to get back on track with some classes. We're going to do some projects now. We're going to be getting into project classes and stuff. We you know, in the past we've done a lot of signs and things and all, but now I want to kind of experiment with some different projects. And this next one is going to be the stair step chair ladder project. If you've never seen that, let me see if I can chair ladder. Bear with me a second. All right, sorry. If we go into my downloads, this is not my design. This is not my plan. This is not my photo. This is, you know, they're out there. You know, people make them all the time, and you know, it's just a very cool project. We are going to go step by step on how to make this project. In case you've ever seen one of these, go, oh, I'd love to make one of them. We're going to go step by step through the design of it in Vectric software. And let me move it over onto the screen as soon as it catches up to itself. And there we go. So this will be the project we're going to be doing next week for you guys and girls. And the ladder chair. So it's a chair that converts into a step ladder. Hell, it could step into a leaning bookshelf. You could put books on that and make it a little bookshelf, a little decorative, for your office or something. When it's in that ladder setup type position and things. The only hardware, besides, screws and things like that, the only hardware needed are the hinges, the, hidden hinges. And I will have a link to those hinges from Rockler or, Eagle America or something like that. I'll have a couple of link options, and I'll try to find the best price for those two hinges. And, but yeah. That's what we're going to be doing. William, an acrylic class project. That's any project, William. Any of the classes that I've taught on any of the signs. Any of the signs can be carved in 3D models, in acrylic. But yes, we can do a cast acrylic class, because one of the things that's different than anything is after we create our design, we mirror it. We got to mirror it. Because we're always carving on the back side of the acrylic, not the face of it. We're carving on the back side, so that way, when you rub your hand along the face of it, you're not feeling all the carving and things. So yes, we'll do an acrylic project class in the next week or two. But next week I want to do this chair ladder. I think it'll be a fun class. This is not my image. I got to give credit to the image owner that I borrowed that from. But we're going to change up the style a lot. It's going to look a little different than this. I haven't drawn up my version of it yet, but that will be next week's class. I think it'll be a fun, pretty cool project. And it'll be able to be carved out of hell, you could make it out of plywood, but it looks better in hardwood. 1x12 material. 1x12 material will be able to cut all the parts for this. And it could be carved on the mini carver or the 2440. Mini carver guys and girls would have to do a little bit of repositioning of their board to cut the parts and stuff, but very easy to do. You don't even need the tiling toolpath. I'm going to show you how to do that without the tiling toolpath. If you have Vectric, desktop, you don't have the ability to tile. So I'll show you how to set that up to where you could carve those parts out. But yeah, that's going to be in Monday's class. All right, ladies and gentlemen, I've already wasted another 15 minutes just talking and rambling. So thank you again. Until next time, happy carving, and I'll see you soon. Peter, I'm not sure if you're still here. Are you asking if a 2x3 is a good 2 foot by 3 foot piece of cast acrylic, or 2 inch by 3 inch for $15? A 12 by 24 3/8 inch thick cast acrylic runs around $26. 12 by 24 by 3/8 runs around $26 from US Plastics. So if that is a 24 by 36 inch piece, depending on how thick it is. For $15, yes, that's a good price. If that is a 2-inch by 3-inch piece for $15, no, that is not a good price. All right. Good night, guys.